Okay, so like I said, many of you are equipped to do the first assignment without any help, but some of you need some guidance, and especially those of you who did Comp 116, you haven't even seen Java. Okay, so what I'm going to do is try to kill two birds here. I'm going to give you a little bit of a lesson on scanning, which is going to be very simple for everybody. Okay, but I'm going to use that as a driving problem to introduce Java to you. Okay, and I'm not going to introduce Java to you formally. Okay, so it's like when you go to a foreign language class, you go to the first class and you're supposed to learn, the basics. But they just start talking to you in French or German, whatever, right? They just say, just talk, and you kind of get an idea. You know English, you know the context. Maybe you can go and answer someone. Okay? So we're going to do it like that. I'm just going to throw code at you and say, try to interpret yourself without giving you any formal definition and see what's going on. And most probably those of you who haven't seen Java also will be able to figure out what's going on. Okay? And I'll show you enough of Java to do the assignment. Okay? So again, those of you who are feeling very handicapped and say, look, what Java book can I buy and how much do I have to study here? Again, I'm not letting you use the full power of Java, right, in this assignment. Okay? So, so you're not at a disadvantage, and hopefully you'll see what you need here. Okay? So with this example, I'll be also not only introducing you to Java, scanning, but also some abstract concepts. Okay? So we know what a problem is. That's what we're trying to solve when we write a computer program. We know what code is. Okay, that's what we write to solve the problem. Algorithm and representation. What might I mean by algorithm? And I'm sure every one of you has heard that term. So this is your chance to show off or to think a little bit. So what might I mean when I say an algorithm? Okay, a set of steps that you go through to get the result. Very good. So is the program an algorithm? Is the code an algorithm? No. His definition is what? Set of steps. Is code a set of steps or sequence of steps?
An equation?
An equation, you're saying an algorithm may be an equation?
Yeah,
so algorithms may involve equations, okay? But, typically it's more than an equation. If you're going to, the analogy people often use is a recipe, okay? So if you're cooking something, it'll be nice, there's a little equation there, but you have to go through a set of steps. And there's no result produced. Well, maybe there is a result, but that's sort of the value created. But, there are things called procedures and functions, and procedures don't return results, and functions return results. So equations might help you with functions, but they're not going to help you much with procedures, okay, unless some step in there. So, but going back to, the definition that we got, which I liked, a set of series of steps, is code an algorithm?
Wouldn't code be more of a language than an algorithm?
So code is written in some language. It's not a language, right? Equation is written in a language, which is a mathematical language. So yes, we will require a language that is probably different from what you're used to in ordinary life. Okay?
You can break code up into methods and classes and get into smaller steps. I guess that follows from saying, well, I want to start with this foundation, and I need to make it this and this.
So you can do stepwise. So is code an algorithm?
I think it can be if you want to code it like that, and it can't be if you code it like that.
By definition, it's a set of steps to solve the problem. It solves the problem. Okay? So it is an algorithm. Now, it might be a very detailed, boring algorithm. When you tell a story or joke, you can give, a long, what is called shaggy dog joke, or I forget what the right term is. But you can tell the joke with a lot of details that are not interesting, or you can get to the point, right? So the boring parts, you want to omit sometimes when you're going to be presenting the algorithm to somebody else. But what's boring, what's not boring, Some detail might be concept to somebody else. So code is absolutely an algorithm. But all code is code. Each program is an algorithm, but each algorithm is not a program. And as you were indicating that when you write code writing using high-level steps, methods perhaps. Okay, and then maybe you in your algorithm you just deal with the method level and you never get into the implementation of the methods. That's also an algorithm that omits certain details. Okay, so the algorithm can be given in English, can be given graphically, can be given in code. They're all algorithms. You can talk of high-level algorithm, low-level algorithm, and code is the lowest of possible levels in an algorithm. Okay, so typically the reason why you guys thought that code is not an algorithm is because you tend to, before you go to the code, you tend to go quote unquote the algorithm, the main points. Then you get to the details. Okay, often the algorithm is language independent. Okay, so it will work for Python, it will work for Java. It doesn't matter. So that's why the answer that look for code you have to know a language, for algorithm you don't have to know a language is true, but you have to know some language. Maybe it's graphical, maybe it's English. Okay, so we get an idea what algorithm is, and we're going to do the scanning problem by first giving an algorithm which is high level, graphical. Then we'll get to the code. Okay, and at the algorithm level, you Comp 116 students should not feel lost. Okay, and it's only at the code level that you'll learn something new. Okay, and because there is a separation, that's why you should feel confident that if you've done programming in any language, you'll be able to survive here, because the important points are in the algorithm. The unimportant, boring things are in the code. Okay, when algorithm is not the code. Representation. Anybody heard that term in your course before? Nobody? Yeah.
Talking about using comments in your code to tell other people how you're doing it.
Using comments to tell, that's documentation. Representation. None of these books you studied had representation? Yeah.
Going to be different types that determine what something is represented as.
Okay, so if I'm going to count numbers, should I make the number so we won't make it a string because to inefficient we'll make it some kind of number type, and we might have, do we have a choice in the various number types? You can use a few number of bits, we can use a large number of bits, we can use a very long number of bits. Okay, and you have the types in Java: short, int, long. Okay, so that's some choice we have to make. So often we first come up with the algorithm where we don't talk about representation. It's a number. Then we go to the next step and say, okay, how are we going to store the number, data structure, or the representation? Then we get to the code. Okay, so that's exactly what we'll do in this class. We'll come up with the algorithm, then we'll come up with the data structures or the representation, and then we'll come to the code. Okay. Okay. Scanning. So we use the word scanning a lot. Okay. We might be scanning images for text. We might be, in ordinary life, we might be scanning frequencies. We might not do it automatically. Our devices might do that for us, or we might actually be flipping through them. Scanning a sentence to find the words in it. Okay, and a computer program, every time you write a program, the compiler has to do a lot of scanning. In fact, most of the time of the compiler goes in scanning. Okay, that's why one of the constraints I put on you is that please do not scan the string more than once. Okay, because that scanning cost is the dominating cost. Okay, and when you're scanning a program, what are you doing? You're saying, what are the various names you define? What are the various identifiers, names for things that identify, names that identify various concepts? What are the operators, plus, minus, you've had? Okay, so what are the numbers there? So that's what you're doing. So I've kind of told you what scanning is by example. Anybody want to try to give a little formal definition of what scanning might mean? Yeah.
Integrating through the components of some kind of range or group, like a string or a list of frequencies.
Okay.
Or identifiable objects being used. Those are the tokens.
Very good. Lovely. Okay. So you're going through some sequence. It's ordered. of some entities, and you're finding some objects in them, which you're calling tokens. So given that there's a sequence of some unit, can you be a little bit more specific about what these objects might be? Sorry? Useful things. But in terms of just, given that that's a sequence, if I have a sequence of 8 characters, could the token be the first, 7th, and 8th character? Could a single token be that?
You can do whatever you made.
Okay, so if you do that, then that's not quite scanning. Scanning would, I'm kind of implying that it's not. And if it's not, then each token would be a subsequence within that sequence. Bunch of consecutive units in that sequence. Okay, that's what it is. And the token could be of length 1 or length multiple. There are seats in front. You don't have to stand in the back. Okay. We're going to see that definition in the next slide. But before we go to that, let's just go do this little simple problem. Okay. How many of you have used the command line in your operating system? Okay, good. Lots of you. Excellent. So, can you try to figure out what's going on here? Can we interpret, what I've just typed in and what came out, what's going on, and what this might have to do with scanning?
Scan string for things letters.
Okay, so what you're doing is you're scanning the string for the uppercase letters, and the tokens here are now J, F, and K. Each one of them is exactly 1 character long. Makes life easy for me. Your assignment is a little harder, and then the project is even harder. Okay, now can we just go and look, but that's semantics. You just told me what this is doing. Let's just go through this syntactically. What is this word Java here? What's it denoting? The Java compiler? Firstly, this is a command line. Let's abstract this out. The first word you type in a command line is typically what? Some program in the operating system. And the rest of the words that occur are called what? Arguments to the program that you ran in the first one. Very good. Okay? So this is some program so what's your name? Christian? Okay, which Christian said was a Java compiler. Okay, we know the word Java exists here. We know Java comes with a compiler, so that's an excellent guess. Okay? And what is the first, okay, so what is the second argument here? It's a program. Excellent. So this is a program and this is a program. That's kind of interesting. To this guy, this is just an argument. But to us, this is a program we wrote. Okay, so that makes sense. A compiler is a program that takes as an argument another program. It compiles it. So that it seems he was right. Okay, so we go and take the Java, whatever it is, program, and to it we give another program. And what is John F. Kennedy now? This is the third argument to. This is the second argument to the Java program, and it's an argument to the second program. It's the first argument of our program, and the second argument of the Java program. Okay. Now the compiler compiles code. We know that. Does the compiler why does the compiler have to? And what does the compiler produce? Executable code. You will pass argument to executable code or to the source code? Executable. So maybe I was right in questioning whether this is a Java compiler. So if it's not the Java compiler, what other thing comes with Java? Java interpreter. Okay. So at this point, this program has been compiled, and this program in Java happens to be called a class. Okay. So this is actually a class that has been compiled by a Java compiler, and what might be the name of that program? Eclipse is a programming environment. it has the compiler in it. So you kind of think that it's got a compiler in it. It's got an interpreter also in it. It's all linked to it. Okay?
The Java virtual machine.
So this is the Java virtual machine, right? This is the Java interpreter. Absolutely. And what's the Java compiler called? What might you call it if you had to give it a name? Very good. If you were a lazy guy, don't want to type Java compiler, what might you call it? Java C. Okay? You don't see that, it's under the hood, but it's something I've already done before. Okay? So this is the Java, so let's see. So this is a program name. This is the first argument or option to the program. And what we see below is the output. Okay? And the first thing is the Java interpreter. And the Java interpreter, just like we had our interpreter, remember? We wrote our interpreter was doing sort of the compilation also, the scanning, everything on the fly. That's inefficient. I told you scanning is very costly. If I have to go and scan the program each time, my programs will be even slower than they are today. Okay? So we first compile it in some compact form, then we interpret it. And so those of you how many of you have seen some C-based language, C, C++? Did you guys have an interpreter there? No. You just said compile, and then out came a file name, and that file name was given as the first argument in your command line. Here we go and have an interpreter also, and in Java we have an interpreter because it's a little louder. It's a higher level language. That is actually normally true, that some of the high-level languages are languages like Prolog and Prolog especially, Scheme also to some degree. So they come with interpreters. So that's a very good intuition. But you can have interpreters for very low-level languages too. If you saw the language we had in the Monty Python demo, that was a very low-level language compared to Java. But we still interpreted it. What's the property of Java that has made it so popular? Objects, but C++ also has objects. C# has objects. Virtual machine, and virtual machine is important because platform independent. Okay, so the whole idea is that we'll write a compiler that compiles the code into some form that is machine independent. And then for each machine, we'll write a virtual machine or an interpreter that will go and interpret it. Okay? And was Java the first language that came up with this idea, you think? So a long time ago, there was a very smart guy from Switzerland called Nikolaus Wirth, who invented a language you might have heard of called Pascal. And at that time, IBM was the big company and still is, and they were dominating with their languages. And he wanted to spread the word with his language. So he said, I want it to be available everywhere. I know people won't write compilers for it. So I will write an interpreter for it and generate what he called P code, Pascal code. And then people just went and wrote interpreters for that, and it caught on. It replaced all the languages IBM had. So that's where this idea first came about, and Java adopted that idea for Java, for object-oriented language. Okay, so I thought I'd change the slide here. Okay, sorry. So we're going to talk about the algorithm right now, and I'm just going to repeat what I said earlier. It's a solution to a problem, can be in any language, okay? And we're going to go and look at an algorithm for this problem, and let's go and first define the problem a little more precisely, okay? So if you're going to define scanning involves a sequence of units. Characters, strings, whatever you might call it. And it involves finding subsequences in them, which we'll call tokens. Okay? And not every unit in that stream is going to be part of some token. Okay? Typically, the stuff that is not part of a token is called white space, because typically it's white space. But in our problem, even the lowercase letters are white spaces, if you will. They are things to be ignored. Okay? So we'll ignore certain things, and to make your first assignment easy, we make sure that the white space is exactly one unit, okay? Just to make it easy as for the regular credit. So there's an input stream or sequence, and there's an there's a stream that you create from it, which is a token stream. And then you can process the token stream even further, and that's what the parser does typically. Okay, the scanner will create the tokens, and the parser will follow the syntax rules. So in John F. Kennedy here, our tokens are J, F, and K, and everything else is a non-token character. Okay, so that's a problem. That's what we have to solve. Now, give me an algorithm for it, and I'm sure you'll come up with very abstract answers to very concrete ones. So let's come up with the most abstract answer to this problem. What do we have to do to find these tokens?
We have to go through each character in that string to see if it matches.
Okay, so we go through each character in the string, and as we go to a character, we go and see whether it is matching or not our constraint, and that matching means seeing whether it's uppercase or not, and then going and outputting that value. Okay, excellent. Now, how will we do so now that's the high level thing. Now let's get down to the next level. There's the what, and there's the next level, then there's the how, which becomes a what for the next level. So we'll just go through many levels here. What does it mean? The simple answer. How do we go and check if something is a uppercase letter or not? Yeah.
The character class in Java has an uppercase match.
Okay, so we rely on magic. Okay, we go and say, hey Java, there's a class there called character, and we'll just go and say is uppercase. We'll give it as an argument the character we have, and it'll tell us whether it's character or not. Who knows? We don't know how it works, but it knows. Okay, so let's just assume that. We'll go and later see how we can ourselves do it without relying on this function. Okay, so that's how we'll do it. Go through each character in the stream. What does that really mean? Let's get down to the next level. Yeah.
You run a for loop, where each square of the variable code identifies a specific spot in the string.
Excellent. See, it's excellent. And you just go through, and after each iteration of the loop, what will happen to that variable? Okay, so we go through that, and so what we need then is a little pointer. Okay, so graphically we need to know where we are. Going through means we need to keep track of where we are. We begin at the very beginning. Okay, and we have to mark where we are. So the for loop is getting down to the code level, but we'll try to be more abstract here. That we need some variable that keeps track of where we are in the string, in the string. Okay. And what we're going to do is, we're going to start that off at 0 or 1. How do we count things? From 0 or 1? 0. So, when you have floors in a building, the bottommost floor is which floor? The first floor or the 0th floor? US, Europe, right? Really confusing. It was confusing for me for sure. So, and it's confusing for me, having seen Pascal, to call the very first thing 0. Okay? And I don't know why, C was a language that started doing this and it's caught on. But, you tend to count from 1. But it's stored in the computer from 0. That's true. But, there's a language that can go and just map properly. But, I find this unintuitive. Some of you may also. So, the 0th element is the first element, right? Okay. So we start the mark at 0, and before we increment, we have to go and check whether it is uppercase or not. And if it is, we output it. We output J. And now we have to look at O. We know it's not uppercase, so we do nothing. We keep increasing the marker. We get F. Keep increasing. K. Now what happens? We don't know what's ahead. So we have to go till the end and stop at that point. Okay? Okay, that's the algorithm. Not very hard. Okay? Doesn't matter whether you've taken 116, 110, whatever. Okay, question? Okay. So now we get to representation. What are the things we have to represent at here? Okay, by the way, so this is the scanning algorithm for this particular problem. For your assignment, I've got a little link from your home page that will give you the algorithm for essentially, your problem there graphically. And that's okay. You can go and look at that. You don't need to at all. But if you want to, you can. So now let's go and figure out the various data types that we might require here. So how might we represent the stream, John F. Kennedy? As what type? String? Did you guys learn strings in 116?
I didn't. I'm old. I didn't take it. No, seriously.
Okay, somebody. I thought you were. So were you 116 students? You did strings? Oh, excellent. I have to worry less now. But otherwise, you can think of it as an array of characters. Okay? But a string is just a specialized array of characters. Okay? So this is a string. And our marker will be what type? Yeah, we'll make it int. We're lazy. We don't want to spell short. But, our strings are probably not going to be very long. But that's an int. Okay? And this is once we choose the string as a type, then each unit is going to be a character. Okay? So we're dealing with 3 data types. Okay? And they're called string, int, and char in Java, for those of you who have not seen Java before. Okay? So how many of you haven't seen Java before? Okay. So you guys are going to be, I'm going to be putting you on the spot now. Okay? So I'm speaking French now, okay, for you guys. And let's try to figure out what I'm saying. So have a look at the code and tell me, anything you understand from it, for those of you who've never seen Java. Or let's just start with the first line. Use your use your imagination. What's the first line probably saying? So it is, say that loudly.
Including the scanning class and
So I'm going to use something, you're saying, and I'm saying I'm importing that. So if I was going to import something, I would say import in Java, as it turns out. Okay? And, this is a small enough problem that hopefully we are not relying on something else. Okay? Even if that something else is, and if we are relying on something else that's closer to the language, and if it's close to the language, we don't have to go and import it. Okay? So it's not quite importing it. What might it mean?
You're naming the program.
I'm naming the program. Okay, so let's go and look at this here. Do you see some correspondence between what I've typed here and what is here? Do you see lectures.scanning somewhere here? You see an uppercase printer here? Can you try to guess now what these 2 units are together trying to say? First name and last name? Yes, location, like state and city. We are Chapel Hill in North Carolina and not Chapel Hill in Louisiana. So what is North Carolina here? So, lectures.scanning, the package. Okay? And Chapel Hill is an uppercase printer. We really want to go and talk about the exact place we are. We say Chapel Hill in North Carolina. I don't know if there's a Chapel Hill in Louisiana or not, but I was in Purdue University. I taught there first, and there was Lafayette in Indiana, there was Lafayette in Louisiana. And I can't tell you how many people took flights to Louisiana when they went to go to West Lafayette. So there was a confusion. Okay? But when we are in this state, we can just say Chapel Hill, right? So that's why we have these 2-level names. When we are in a folder, we can just go and talk of the file in the folder directly, right? We don't have to go and say D, backup or whatever. But when we are somewhere in another drive, then we have to give the full name. Okay? So does the folder analogy somehow, can you see why the folder analogy is actually a very precise analogy for what might be going on here? So a package is like a folder. For those of you programmed in Java, you know that a class is a file. If a class is a file, then a package is a folder in which the file resides. In fact, that's exactly what's going on here. The lectures.scanning, lecture scanning is a folder in your directory, and uppercase printer is a file in there. Okay? So this is our package, and How many of you have actually gone and installed Eclipse? How many of you have not installed Eclipse so far? Please do. Have you had trouble or you have not had a chance? Please get the chance today. Sorry? You've dealt with it. In my homepage, there are detailed instructions on how to go and create an Eclipse project. And I also tell you how to create a package. Okay, so even if you've never created packages before, you can do it. I can tell you.
Did you personally put the period after lectures? Did you type in lectures.skin when you created your package name?
I put the period here. Yes, lectures.scanning. I put it in.
Okay, does that automatically then separate it out into two folders?
Yes. So when you go and create it in Eclipse, it'll automatically create a folder for you. You don't have to use Eclipse. You can create a folder called lecture scanning, put a file using Emacs or whatever your favorite editor is. I know you use Linux-based systems. So you just create that folder. In that folder, you create a file there, and it'll be interpreted as a package. Okay? But you better go and put lectures.scanning in your file, in your class. If you go and put the class in some folder that is not lecture scanning, Java will complain. Compiler will complain, and things will go messy. Okay?
Do we specifically use the 3.7 version that was in your PowerPoint, or do you want us to talk about the
Which version of PowerPoint am I using? What, 3.7?
which version of Eclipse? What version of Eclipse do you want us to use?
Okay.
PowerPoint says 3.7.
Okay. I don't even care if you use Eclipse or you don't use Eclipse. Okay? I think Eclipse is, the most wonderful thing that's happened in computer science almost. It's buggy. So the latest versions might be a little buggy, but please use the latest version. I don't update my slides each time I teach the course, and Eclipse keeps up. They do more work than I do, I guess. So, but I know some of you want to use NetBeans, you want to use, I don't recommend it. I think Eclipse is really wonderful, and it's made my life so much. I love to program now. Okay? I never used to program before Eclipse. As a professor, you don't have to program. You just have to pretend you know about programming. Really, I'm not joking here. Okay? You can use anything. And by the way, we still don't have a TAs. As we speak, they're trying to assign TAs. Most probably, 99%, we're going to have recitation tomorrow. In case we don't, I'll post something on Piazza, but be ready to be there. Okay? I have to find them. I have to go and send emails to them. So there's a lot of things that have to happen before now and 11 o'clock, but hopefully they'll all happen. Okay? Okay. So we know what these two words mean. Now, what's this magic? Public static void main string args. It's the main starting point. Okay, it's the main method. More abstractly, when I go and tell Java, here's the name of a class. What can go wrong at this point? What can Java say did not happen? It did not have a main method. It did not have a main. Not every class or not every thing that you call a class. We'll see exactly what classes mean later. But if you want to run something, that's got to be a class. It's got to be a class with these magic words. Okay? And they are not so magic, right? Well, public, static, what do you think public means here? So a little louder. Other classes can access it. In particular, who can access it? Who needs to be here? Who needs to be able to access this class? You or the interpreter. Okay? So the interpreter should be able to, other people outside what? Outside outside the class. Yeah. But a class is inside so other things outside the package can access it. Okay? So Chapel Hill is a name that you can, even if you're in Louisiana, you can go and give that name. That's what it really means. Okay? And the interpreter is outside everything, so the interpreter can access it. And that's what this public means. This public means that other classes even in the same package, but different classes can access main. Okay, so we have to first make our class available to everybody, then we have to make the main method in the class available to every other class also in that package. So we are saying that main is available visible outside this class, and this public means an uppercase printer is available outside the package. Okay, so so public means the interpreter can access it. Static, it's just something you add, just for flavor. It can't change. It's not dynamic. So we don't know what dynamic is, so we won't say what static is right now. Just, because Java is object-oriented means dynamic, whatever that means, we'll get to that later. And here we are not being object-oriented. Yeah, we're using the word class, but we're just cheating. Okay? So we're just basically saying we are not being object-oriented. We are programming as we would program in Pascal. Okay? It's just that we're using Java syntax. Okay? So we are not, so that's what the static means. And this void means it doesn't return a value. Okay? And main, we have to give a name to the starting point. We'll call it main. And what's going on here? So remember, we have arguments right here. How many arguments can a program have? As many as you want. And all of these arguments will be then returned to you as what type is this? As a string, as a single string? As an array of strings. A string is something you can decompose into characters. That's one level decomposition. Plus the strings themselves are combined into an array. So we have two-level decomposition. Okay? Args gets broken up into different arrays, and each array gets broken up into different arg is an array that gets broken into multiple strings, and each string can be broken up into multiple characters. Okay? Okay, we got past the first 3 lines. Okay. So what's happening here? What am I doing? So how many arguments are we expecting here, the program? 1. Exactly. So if they gave more than 1 argument, they're confused. They're probably running the wrong program. Okay? Or if they give 0 arguments, they're confused. So we say this. Okay, and what's happening here? Scan string equals arg0. So how we are initializing this string to hold. I'm just giving it a name. I'm saying, arg0 is going to be my scan string. So what is this operator called? Equals? Assignment. Okay, it's not that they're equal. I'm not declaring they're equal. In Pascal, if I was saying equals, that would what it would mean. This is the right-hand side. We are assigning this value to this value. Okay? And what's this saying? So we are just printing something. We got a very long name for it. System.out.println. Who knows why we're having such a long name? We'll figure that out at some point. But that's a long name. And within quotes is a string that we want printed out. And it prints out on the console. That's how we got uppercase letters here. And ln means after that, the next print should go on the next line. Okay? System.exit -1. So you're just stopping, and -1 might mean error. 0 means nothing bad happened. -1 is some code that somebody might interpret in some way. Okay? Now it's easy. I've got an int type. I'm assigning to it. I'm not using a for loop. I know somebody said for loop, but I'm using while because it's very general. Okay? And I don't want to get into for loops right now. So I just go and assign to index the zero value. I have to check whether I reached the end or not. Okay? That's your loop that you were going through. I go and take the character at index. I assign that to next letter. Okay? I go and do this magic, and it'll tell me if it is, this is how I do a conditional, okay, Boolean expression, and I do print rather than print line because I want each of these to be printed on the same line. Okay, so I don't want an ln after that. I increment index, and in the end, I go and put a line. Okay? All you 116 students, any questions? Yeah. Exclamation. Ah, sorry. Not equal to. Okay. So which language have you used before? Well, how do they do not? Not equals? Left, and right? Oh, tilde. Oh, interesting. Okay. In Pascal, it was, I think, less than and greater than. You put them both together. Other questions? Static means not dynamic, and we don't know what dynamic means. So it's just something we put for flavor right now. Okay, but do it. It means we're not programming object-oriented. In next lecture, you'll get an idea what it means. Yeah? Yes, absolutely. No, but I pointed you to a set of slide deck which has for loops and everything. Okay? So I said, go look there. Okay? And in 10 minutes, within 10 minutes, if I'm lucky, we'll be able to. If you're lucky, I'm lucky, we'll be able to do for loops also. Okay? Other things? So where did the input JFK come from? Where did John F. Kennedy come from? Did the user type it in the console?
Well, in Eclipse, you have a slide deck that shows you where to enter it in the
Yeah, but so you said input, right? I typed it on the same line. This is an argument. And this is the argument's 0th argument that I got. So it's not console. I never did a read here. I'll get to read also eventually. Okay? Other things?
What's the purpose of the -1 after system exit?
It's just saying that I did not terminate gracefully. Exit 0 means I did what I was meant to do, I'm done. Exit -1 said, something went wrong. Okay? And somebody else can go and look at that error code value and interpret that somehow. Okay?
So I'm a little confused with args. I'm familiar with the main method of using string args and parentheses like that, but I never knew you could use it as just like a variable. I guess what you've done.
So, you guys all write in public static void main string args. Every one of these things should have some purpose, right? And I guess if you've learned Java before, your instructor told you there are args here and never told you what args is about. That was not a very good thing to do, right? So, so I'm telling you why there's args. And I'm giving you an example here to show that, every program has args. If you've ever used a command line, and you have because you're a Unix guy, you have to somehow get hold of the args. And those args come from the interpreter. Somebody who ran the program got the arguments. So you're going to have this main method that's going to call other methods and pass arguments to it, but your main method itself can get arguments. It doesn't have to get arguments. So when you were taught Java before, you were taught programs that never got arguments. And you just put args there for the sake of putting args. Because they may be arguments. Okay? That's why you always got an argument array with length 0. But now we have an argument array that has got length 1. And when it's of length 1, there is an argument 0 is going to hold some value. That is our input. That is where John F. Kennedy is. And that is where we're going to pass. So there's no console input here. Okay? Okay.
Under the second if statement, what does the index mean?
Very good. Which language have you used?
MATLAB.
So when you have to increment something, how do you increment? You just say index.
You say index equals index plus 1.
So this is shorthand for that. Okay? Index is assigned index plus 1. As it turns out, this is shorthand for you. The compiler can do smarter things when it knows you're incrementing. Okay? Good. I'm glad you're asking all these questions. Okay. Okay. Now, Now, how could I not use magic is uppercase? Anybody want to guess? Yes. Sorry, a little louder.
Take the character code. You can look at the character code for each of the characters.
Okay.
And see if they're within the uppercase range.
Okay, so you can go and say, okay, that's interesting. So every character is stored as an int, and that's its character code. And then you can go and say, if the character code is 64, it must be A. If it's 60, for B, what? If A is 64, B will be what? Okay, you can rely on that. So you can look at a range. Okay? And I can just say, so these are library operations. This is, I tell this. I can just say this. If next letter is greater than equal to capital A, and next letter is less than equal to Z, then it's a uppercase. Okay? Because characters are ordered. Okay? Okay. But you don't have to do it this way. You're welcome to write your function. Okay, so I want to again make a distinction between getting something from as a program argument and reading something from the console. Okay? Now we are going to read something from the console. Okay? So this is the kind of programs that you guys have all written, those of you who have never seen arguments before. Okay? We're just going to ignore arguments. Assume no arguments exist. Okay? And we want to go and get the next line. Now, there's system.out.print and print line. So you might think there's something called system.in.readline. There isn't. Okay? But we can simulate that, and we will simulate that. But there are many ways to do input. Java was not a very strong language for input reading from the input. But this is what you can do. You go and do some magic. You'd say new scanner system.in, which is, for those of you who know object-oriented languages, this is where I'm getting very dynamic. But you just put this magic code here to create this particular scanner object, and then you say scanner.nextLine. Okay? And then you can say scanner.nextLine again and again to get the future lines. Okay? So this is somewhat magic. I have a class called console where you can just say console.readline. But for that, you have to include my library, and I don't want to force you to do that. But that gets me away from using the word new very early in class. But for now, just think of this as a little bit of magic. Okay? And the rest of the code remains the same. Okay? I've read that into scan string, and I go and do what I did earlier. Okay? So you may not conceptually understand why I'm doing a new here, except that, we are not going to do input on our own. We are relying on somebody else to do input for us. And that somebody else is going to actually dictate how we go and use it. And so that somebody else said, please do a new here, and then you can do a next line after that. Okay?
So will we be using standard for first assignment?
Sorry?
Will we be using that for?
You can. And if you use the scanner, and if you read the assignment, I say, do not use any method other than next line from scanner object. Okay? And that's one way. You guys might have used this before. There are other ways to do input too. But I'm not allowing you to use any method other than next line in scanner object. Is there a next string? How can it be? Which are you running some Mac version or you? Okay, and next string just gets the next. Is it the same as next line? Okay. Okay. Other questions? Yeah.
Saying scanner.nextLine, the same thing as saying keyboard.nextLine.
Is there a keyboard class in Java?
Yeah.
You don't have to do new. You just can say keyboard.nextLine.
Well, you have to set it up the same way.
Sorry, just one.
You set it up the same way with the scanner, and then you can.
So you have to do a new. You have to do a new keyboard, or can you just say keyboard.nextLine?
You have to do a new keyboard.
As long as you get just a line and don't do any scanning, you're fine. But I don't know why they have keyboard and scanner. I guess keyboard is less powerful. Yeah. Oh, is that what keyboard is doing? Yeah. Okay. But just, if you don't have next line, use the read string. If you don't have scanner, use keyboard. That's fine. There's input, buffer string. There's all kinds of ways. Okay? Questions? Okay. I have 1 minute, so I'm going to take that 1 minute. So this works. And I put a constraint on you that, write your code nicely. And I put a constraint that don't write it all in one method. So how could this is all in one method. Is the problem so simple that I can't use more than one method, or could you use more than one method here? You could use more than one method. Somebody want to tell me how to break this up into more than one method? Because that's something you have to do in the assignment. And I'd like to go and at least spend 30 seconds on it. So you'd put the while loop in another method?
That way, for each line of each string that comes in, send it to another method.
Yeah.
Not just the while loop, but I would create a completely separate method for scanning itself, so that it would be variable instead of saying only scanning the capital letters.
Okay. So let me just say very loudly what these guys said. And one way to break up this code into multiple methods is to put this loop in another method. And you can even be more ambitious than that. So let me quickly show you that. By the way, maybe I won't show you that and maybe explain this properly. So why did I go and do an import here? Now this is where I'm saying I'm using a library that's not part of the language. So I have to go and tell Java that I need to import it. Okay? So I say import java.util.scanner. And if it's the external library, yeah.
So the library not a package?
You're importing a package. You're importing a package and a class. Importing scanners from the java.util package. Okay? And this is a library package. This is a library class. Okay? And there's enough information for you guys who've never done Java before to, I think, do the assignment on next Tuesday. But we'll elaborate on this next Tuesday. Okay, great. So, the class is managed just not by me, but by these guys also. In fact, you'll be seeing more of them outside class than me in many ways. They'll be doing the recitation, they'll be having office hours, they'll be doing all the grading, and they'll be doing a few other tasks also, such as, I won't get into those right now. Okay, so thank you. Okay, any questions? So I know after I finish class, there's a long line of you who come forms and want to ask specific questions. And trust me, if you have a question, there's probably 10 other people who have the same question. Okay? And the whole idea here is that, we can't really, it's not very efficient to give individual answers. So don't feel shy about asking questions in public. The more shy you feel, the less you'll learn. So you've got to have a little bit of a thick skin or to really learn, I think, anything. So whatever question you were going to come ask me later, you want to ask right now? Yes, good.
Is the rubric available for the first assignment?
Okay, guys, so the rubric will be available when?
Yeah, I posted it on Piazza last night.
Okay, so it's posted on Piazza. If anybody is not enrolled in Piazza, please do. That will be the mechanism for making announcements. Okay? And so I suggested one correction today.
Yes.
So just keep looking at the rubric might change, and you'll get notifications about changes too. Okay. In fact, that's what we'll do. We'll put a draft one as soon as possible, so that you have some idea, and then as we discuss it more and as we get feedback, we'll change. In fact, the last time I taught this course, I had students propose rubrics. And so that was good because, you guys really know how much work was involved. And 2 or 3 students got into it. Nobody else did, so we kind of gave up on that idea. But if you want to propose rubrics or propose, say, look, this seems disproportionate, please do. Because it's sometimes it's very hard for us to put ourselves in your places, okay, and know how much, how difficult it is for you, what may be easy for us, okay. So things might evolve, and by Wednesday midnight for sure, we'll by Wednesday morning, hopefully in general, it'll be cast in stone. Okay, so that you can submit early. Other questions? Yes.
If you start a line with a period and then have numbers after it, should it just terminate or should it still terminate?
What do you think?
Should it just terminate?
Up to you. Okay, that's an error condition. And error conditions are up to you. I say it's a line that contains exactly one period. Okay, when it's not that, whatever's convenient. Okay, error reporting is such a difficult task. I was going to say pain, and that's why people don't do a very good job of it. Even in industry code, you might have seen blue screens just because people don't do all the error checking, and that's why I didn't make it mandatory to do error checking. And as you find time to do things, go ahead and add these things because they're very important. Okay, from a user's point of view, they're very important. Even from a programmer's point of view, from another programmer's point of view, it's important to know what the previous programmer did by just looking at the error codes. Yeah.
For the screenshot, we just submit one or we submit as many test cases as possible.
So what do I say in the assignment? Sorry?
The rubric just says.
No, what do I say in the assignment? Okay, so you have to read, some of these things you have to read carefully. And I think what I say is, and the thing is that I'll often ask you, what do I say in the assignment? Because I have forgotten what I said in the assignment. And I don't want to say something conflicting. Okay, so if somebody says, is this allowed, I always say, go look at the assignment. Okay, firstly, I want you to read the assignment. I don't want you to come individually, each one of you, and say, is this in the assignment, when you could have read it. So I think what I say is, anybody remember what I say in the assignment? About how many screenshots to submit? Yeah.
You said to submit how many screenshots prove every aspect of your program. So if you have some error handling, make sure the screenshot
Okay.
shows it.
I think he's phrased it better than I did in the assignment, that you show as many assignments as are needed to show the functionality you've implemented. Okay? So if you are handling period, in the error case, in which there's a period followed by a number, show off that feature and say, look, I handled this too. Okay? And the TAs may or may not run your program. Okay? So it should be possible for them to just look at the screenshots and know what you've implemented. And then they can just look at the code and say, okay, does the code seem consistent with the screenshots? Okay?
On the method that we could use, which is just in the assignment, one of them was next string.
Oh, sorry, what string?
Next string.
Yeah, I think I changed it.
I don't think it exists.
Yeah, there was a whole Piazza discussion on this, and if you look at the assignment, it's corrected to next line. Okay? Yeah. How do you fill the rubric? So when you see the rubric and there's been a message there, just go look at the rubric. There'll be a table there where it says, tell us what features you've implemented. And here's the set of features. Here are the things that we are going to grade you on. And tell us whether you implemented that feature or not. No. So when you will submit the rubric as part in Sakai. You will create a copy of the rubric, you'll fill it up, and when you go and upload your assignment directory, you'll also upload the rubric and the screenshots. So have you ever done a Sakai upload? I haven't, so I'm actually, you guys know better than me, but isn't there a way to go and upload files in directories? There is. Okay? So there's a way to upload a file in a directory, so I'm not sure.
Should rubric be like files? Can we just put it in the section where we just
A separate file. Okay? That's the easiest. You get a file, you change the file, you submit the file. Okay? At some point, we might have an automatic grading system working, where we'll tell you exactly, we might constrain a little bit more how you upload things. Okay? Other things? How many of you are still waiting to get in? Wonderful. Nobody. Okay, great. Okay. So I still passed the attendance sheet around just in case there were more people waiting because, wanted to see who's in, who's not in. And I might take, I always thought taking attendance would be very disruptive. It doesn't seem that disruptive to me. I don't even notice you guys for putting your names in. So we might do this more frequently. as a student, I never liked the idea of a professor enforcing attendance. But there's enough research to show that your grades are very strongly correlated with your attendance in class. Okay? And especially in my course, where all this material is available outside, you might be tempted to think that you can always look at this later. I think I mentioned this earlier. And that later time never occurs because of other deadlines. So this is to make sure that you're sort of a captive audience here, learning things. Okay. So if I see the class thinning down, if I see, people that stop coming, I might start taking attendance sporadically. Okay? Okay, so we were looking at this code, and we were doing a scanning problem. And when you scan something, when you're doing a scanning problem, you need some source to scan. And we earlier looked at a problem where the scan string came as an argument to main. Okay? And because of that, and that made us appreciate what this argument to main is. It's a string of, it's a array of arguments entered by the user. Okay? And that's one place where the string to be scanned could come from. And another place is from the console. Okay? When it comes from the console, we say that's input. Okay? When it comes from an argument, it's not really input, it's a program argument. It's something that the user might have entered, so you think of that as input, but it's not console input. And when we normally talk of input, we talk of console input. Okay. And our code is very similar to the code we wrote earlier, but now we had to go, we are using some external library, and it's external, it's a library because it does some things for us. It's external because we had to do this import. Okay, it's not something that comes automatically as part of the language. Okay. The string is a class, is a library that comes part of the language. You don't have to import it. Okay? But the scanner is something that you import, and you do some magic to make to create essentially what's called an instance. And then once you've done this magic, you can take the scanner object and keep saying next line again and again, which is what we saw in class last time. I guess here you just do it once. Okay? And then now that you got the scan string, the rest of the code is the same as in the previous problem, where instead of scanning the argument, you're scanning the input. Okay, so and we are here making use of the fact that letters are ordered. So we are not using is uppercase. We are just using the fact that they are ordered in order. Okay, and just to emphasize the difference between external and internal library, if I don't put the import here, what will Echo tell me? Say, yeah. Okay, so this is the library package, library class, and if I omit the import, it'll give me an error. Okay, and how can I fix the error? Okay, so the lazy approach. What somebody else said? So you can type in what I just typed in there. Okay, and that's the difficult thing. And the lazy approach is?
In the left-hand column, there will red mark, and then it'll suggest you.
Okay, so you'll get a little error, and if you hover over the error, it'll tell you what the error is. If you click on it, it'll go and give you ways to fix it. And in general, you can just press Control-Shift-O, and it'll automatically import all the things you haven't imported. Okay, and so that's the easiest thing to do. Okay. And so often I'm just going to give you the class name. I won't give you the whole package name, what to import. And I'm assuming that you can do Control-Shift-O to get the right thing. Okay. The problem with this command could be, if you could do Control-Shift-O, why does Java insist on an import? If the system can automatically figure out what you want, why have an import?
Extra processing that would be unnecessary.
So you're just saying making the compiler more efficient? That this way you typed it in, so the compiler doesn't have to do the search. Okay, that's a good answer. Any other? Yeah.
You could create your own method or class name or something else to import.
You can create your own class called scanner, and then the question is it your class or is it the other class? Is it Chapel Hill in North Carolina or Chapel Hill in some other state? Okay, so as long as there's only one Chapel Hill, Control-Shift-O works fine. Otherwise, Control-Shift-O will tell you, okay, I found these 3 Chapel Hills. Which one do you want? Okay? So that's the reason why there is an import. Okay. So that's okay. So this is sort of packages and imports, and I'm going through this quickly. And there's another chapter that discusses this in more depth. Okay. Now the code we wrote is, and I'm using, I guess, a technical word, monolithic. And I saw in Piazza that some of you were confused as to what that meant. Why is this method monolithic? Why is this code monolithic? So there's only one class, and that class has how many methods? Exactly one method, and everything is in that method. Okay, now, usually when you see your first Java program, it's hello world. And hello world happens to, be in that one main method. So that doesn't seem like a wrong thing to do. In this case, what I wrote, is it wrong? Could I have done better? Could I have, how could I go and break, and this is the question I posed last time when we left. How could I break this into smaller pieces that make sense? Not for the sake of breaking into pieces, but that makes sense. And what criteria do we use to decide what makes sense? And, somebody posed this question in Piazza and somebody answered, what was an answer, or what is the answer possible? Yeah. Okay, so sometimes some things that you might reuse multiple times. Okay? So you can create a boombox with all the components sort of one bundle together. Or you can say, this speaker can be used with this amplifier and that amplifier, so I'm just going to make that a separate commodity, and then we can go and reuse it for different systems. Okay? And is there any other reason to make it modular? Yeah. Sorry? Group similar pieces together because, sorry? It makes sense that way, yeah?
If you change what you want to import to take in, you just go to that separate method, repeat that, then have to go through your entire main method.
If you want to change something, now that you put your speaker as a separate commodity, if there's no sound, I have to just deal with the speaker perhaps. I don't have to deal with the whole piece. Okay. Any other reason? Understandable, makes it more understandable, and easy to read it. So that's reuse. Right. Good.
If you have a team working on a project, one person can start with different methods. You don't have to have one.
Right. So you can have the speaker team, and you can have the amplifier team, and and they just don't have to worry about each other as long as the interfaces, as long as the boundaries between them are well established. Okay. Okay. Now that we have all these principles and reasons, can we look at this code and see how we could separate this into multiple units? And we won't go to multiple classes right now. We'll just go to multiple methods in one class, which is your task also in your assignment. Yeah.
One method to create would be separating off the declaration of the index and the loop that follows it.
So you're saying the index and the loop that follows it could go into one method? And what would you call that method? Scan. Scan, and does it just scan, or does it do something else also? Right, and prints. Okay? Parsing is something that goes on top of scanning, and so that's something we'll see later. Okay? Any other ways of decomposing? I mean, that sounds pretty good to me, but I'm just wondering. Yeah.
Maybe you can make two methods, one that like reads the input, and then the other one that does the feedback, and then just put both those methods in the main method.
Okay, that's an excellent idea. Why not go and take these two pieces, these three lines, and put that in a separate method? Okay, and then your main method just calls these two things. Okay, so I'm not going to be as good as that. Okay, but by doing this, are we gaining anything? Okay, so modularity, all that stuff is good. Are we going to increase our reuse in some way? Yeah.
Not unless it's in its own object. It's really hard. It would be hard to reuse method.
So you're saying it's hard to reuse methods unless you sort of do object-oriented programming, which we haven't done so far. Okay, let's see. So I wasn't as good as you suggested, but I certainly did the kind of the obvious thing, that I did scan and sprint, and I said, we'll have main do something, and the main just reads it in and calls scan and print. Okay? And you see the methods being called, that this particular piece of code reads something into scan string, and scan string then becomes an argument to this particular method, and this method does the rest. Okay? Now, method, decomposing a program into methods is something that I really expect you guys to know. Okay? And I assume you learned that in Comp 116. I assume you learned that in Comp 110. So we are going to be doing far more fancy decomposition later. So this much you should know. Okay? In terms of Java syntax, again, the Comp 116 students, anything funny going on here that seems mysterious? Okay, not too hard. I mean, this is pretty much in how in most languages you give the method name, you give the arguments, and you give the method declaration here. And we've seen how to declare main. The declaring this particular method is also very similar. And this takes args as array of args as an argument. This takes the scan string as an argument. And this is our speaker. This just does its thing. It doesn't know how things were read in. Okay. Can you tell me? So this is the one that reads from console. This is the one that reads that scans the argument entered on the command line. How could I decompose this? Same way? Yeah.
You could separate out the error checking.
Okay, so the error checking would be, so this part would be common, would be say in the main method or in a separate method, and this part would again be, and I would call that method. Now I already have a scan and print from the other one. Can I just reuse that one? Sorry? If you import it. Importing is relevant only when there are, multiple packages. As it turns out, I've got them all in the same package. So I don't even have to import it. How would I call that method, by the way? How would I call a method in another class? So somehow you have to tell it this class and this method. Okay? And here's how we do it. We keep this code. Again, I'm not being as good as I could have been. Okay? And I'm saying whatever my other class was, please go and call the scan and print of that. And I'm just going to pass my arg0. It's going to do the scanning. So this thing we did to understand things, to make it modular, suddenly allows us reuse also. Okay? So reuse is sort of the practical benefit from all of this stuff. Okay? Anything mysterious here? So you see the motivation for making things modular, and you see how one could go about doing it. Okay? Questions? Yeah.
Just kind of like briefly on the submit. So the first line I think is class, right? And then
Sorry, this here, this is the package first.
yeah.
Then this is the state you're in.
Right.
This is the city you're in.
Right.
And this is the, I don't know, the building you're in.
We're talking about violence is a modular console reading uppercase turned out.
So that was the name of the class. Just as this is called the modular uppercase printer. A modular console reading uppercase printer. You like this name, by the way? My names are essays.
And then so you put the dot and scan first from the previous.
So I basically need to provide somehow the class name and the method name and the arguments. Then we need some syntax, okay? But the concept is that I need the class, I need the method, and this is just the syntax. Yeah. So this is the target of the method. Think of this as what you're invoking the method on. This is the method, these are the arguments. Okay? So even if you're not doing object-oriented programming, reuse is possible. Okay? You just have a different level of reuse with object-oriented programming. Okay? Okay. Yeah.
If you call a method and you call it into a different class, and you have a variable defined in that class, can you put a variable into the parameters of that method to have a method?
So you're saying that here I've said here I've called a method in a particular class that is not my class. You're saying this is an interesting idea. What else can I access from that class? Is that your question? Can I access the variables in that class also?
Right.
So what does this word public mean? What do you think it might mean in this context?
Accessible to other
Classes. It's accessible to other classes. And if I was to make a variable public, which I should never do, okay, I would be able to access the variable also. But okay, so Java lets you do it, but this class will never let you do it. In this course, imagine that that's taboo. And we'll get into that soon, maybe even today. Okay? Other questions? Yeah.
Are there cases where it's okay to make a variable public?
To every rule there is an. So, I mean, the Java, the guys who design Java are pretty smart guys. So since they allow this, there must be a reason. I'm not sure. There are times when I become lazy and I say, I'm just going to make something variable public because I think of all the reasons why I shouldn't do it, and those don't apply there. But every time I've done that, I've been bitten later because I couldn't think deep enough. So if you're 100% sure that nothing bad will happen, then you do it. But my recommendation is just never do it. At least in this class, don't do it. Okay? Okay, other questions? Okay, so I have, through this problem, told you more or less all the things you need to do your assignment. And the one thing I haven't talked about, which was in the class material I put in the assignment, is the substring thing. So what is the substring method? In general, I'm showing it being used here. So in general, the substring method does what in English? Yeah.
We're able to abstract index of the string and then make arguments or
So from a string, you're able to create chunks of contiguous characters. Okay? And so the first argument is the start point. And the next argument, I can never remember that, is the end point, which means what? Which means the last index of the last character to be gotten, or the index beyond that? Index beyond that. So what will hello world substring 47 give you? So we start counting 0, 1, 2, 3, we get O, 4, 5, 6, do we get R? Okay. 4, 4 will give you what? This is the index of the last character to be gotten, or the character after the last one? So it will be a string of length, and it will be a null value. It's a string. It's a null string. It's not the same as a null value. It's a string with nothing in it. It's a string with 0 characters in it. Okay? And 7, 4 will give you what? Okay, begin index and end index. So basically you get all the characters from begin index to end index minus 1. So this is going to give you this. This is going to give you nothing. Okay, just between quotes nothing. Okay, it's a null string. And this is going to give you an error. And errors in Java are called exceptions. Okay. There was a question in Piazza, how can I append to a string? Okay, and I assume you guys were thinking that, okay, I'll go to one character, then I'll go to another character, I'll append that to the string, and so forth. You don't need append. I didn't tell you about append. You don't need a concat. You can just get the chunk you need. You just have to figure out, here's the index, start index, here's the end index, and then you get all of the characters in one chunk. You don't have to go and build the chunks up. Okay? So I didn't tell you about it, and you don't need it. Okay? Questions about this? I know there were some people either didn't know about this or didn't know how to use it. Okay, if you don't know how to use it, that's another issue. That's where you need to sort of hone your programming skills. But at least you know what it does. Okay, and that's how you can get tokens of more than one character. Questions? Okay, good. And another thing you have to do is convert a string into an int. Okay, and I told you how to do it. Okay, and now can you guys figure out what this integer.parseInt is? Can you break this syntax up? It was magic for you, right? You just typed in integer.parseInt and you did that. But what is integer here? And this is a... So you've been using this actually. Okay? And it was just magic to you, now you know what the syntax is like. And what do you think I'm doing around it? I made things more complicated than you need to do it. Just by example, without giving into depth, what's going on here? What's this try? What's this catch?
It's a block where an exception might happen. So you try it, and if the exception occurs, you have to change.
Okay. So the whole idea is you're saying, you can do things confidently or you can do things tentatively. Okay? And when you know things will work just fine, you say, okay, I'm going gung-ho, I'm very confident. And when you're just tentative, you say, I'm going to try. So if I say, can you do the extra credit? You can say, of course. Or you can say, I'll try. Okay? And try means I might fail. And I might fail not because of something bad I'm doing, but because of something bad I might have got. So this read int is doing scanner.nextLine. Who knows whether the next line is something that can be converted into an integer or not? We don't know that. So one thing is to just throw up your hands and say, the instructor says no errors can occur, so, I don't have to worry about it. Okay? Or say, I will catch the error. My own code will catch the error and will do something in response to it. And the typical thing people do, and we'll get into exceptions in much more depth later, but I just want to show you this code because just to give you an idea what's to come, and you can't really do much programming in Java without doing something about exceptions. Okay? So that's what's really going on, that if this code succeeds properly, then this code will not be executed, the one in the catch block. Otherwise, the catch block will be executed, and you're just going and printing out the stack trace, where I am in the code. And you can also print out, instead of doing that, or in addition to doing that, you can print out the exception, such as null pointer exception. And so this is what the JVM essentially does. If you don't catch the exception, it'll go and print these things out for you. Okay? And you can see why I keep getting confused with read line and read string, because my own class console has this read string method as opposed to read int, and which does the next line. Okay? So, and if there's some problem with the next line, I'm going to just again, and notice that I'm returning a value. Okay? So if I have an error, I don't just, I catch the exception, but this particular function still needs a value, so I'm returning 0, and in this case, I'm returning the null value. Okay, so I'm doing some kind of error recovery. And you don't have to do any of this stuff right now, but I'm just giving you a preview so that you understand to some extent what's happening when exceptions get thrown in. Okay? In terms of understanding this example, not the concept, any questions? Okay. Now that I have this console class, how could I use this console class? Is this a useful class for you to use, by the way? Because you can do the read int, read string. And is this method useful for you also, read string? You have a next line. What does this add to next line? This class. You don't have to instantiate the scanner. Okay, that's done for you. So here I'm showing you this being used. I can just say console.readInt. I wish Java had just done that. Okay, so I don't have to explain to you what instantiation is the very first day of class to do input. Just say, here's a console class. Just do a read string from that or read int from that, and you get the input. Don't have to go and say new scanner, new buffer input stream, all that stuff that you have to say in a long-winded way. Okay? So now this is a class that we formed, and I'm going to reuse it here. Okay? So what am I doing? I'm saying, I'm going to now, there's some more reading here. It's a little different reading from what you do in your assignment. How is this different? Can you figure out from this code how what I'm reading is different from what you guys are reading? Yeah. So the user we know how many strings are going to come. We don't have to wait for a dot or a dot followed by a number, who knows what, right? And I'm going to, and that input, what am I doing with that, with the string that I read? Sorry? So I'm reading it as an integer. Okay, that's one thing I'm doing. And that is the number of strings. And then I go and read those many elements And this read string, what am I doing with it? Storing it in an array. Okay? A lot of you guys were saying, oh, can we use arrays or array lists, which is something more fancy? And I said, yes, if it makes your code more modular. Okay? And one of the things you might want to do is just read a bunch of input and give it to some other method as an array, which is what this is doing. Okay? I'm not doing another method, but I put this in an array. And by the way, what does this dynamic array mean here? Yeah. So it's a little louder. You said the users can update the array?
Well, the user decides whenever they enter the user how big it's going to be.
So the size of the array was fixed at runtime. It wasn't fixed when the program was written. That's a big deal for me because the first languages I learned, all the arrays were fixed at program writing time. This is nice. You can read an input variable from the user and then allocate an array that big. Okay? That's what dynamic array means. But once the array is created, its size can't change. Okay? If you want to simulate something whose size can change, either you create your own object, which we'll see, or you use an array list or a vector. Okay? And this particular piece of code prints the array input in the previous loop. Okay? No mysteries here, except I'm using a for loop. Now you guys see how a for loop works. Okay? You see two examples of for loops where you initialize, the variable is declared in the loop itself, and this tells you when you should terminate the loop, and this tells you what to do after each iteration. Okay? So if you use any form of for, even in Comp 116, you can probably understand what this is doing. Okay? So you don't have to just use while loops, you can use for loops. Okay, that was allowed. And what am I doing here? So strings is the array I filled in. And it's an array of strings. So what am I doing here? Printing all the strings I read or the first one. And I'm printing out each what in the string? Each character. Okay? So I've got an array of strings. A string itself you can think of it being an array of characters. It's not an array, it's a string. And I'm printing out. And why do I say this is unsafe? Yeah. The user might have said 0, in which case we read no string, and then my code is going to bomb on me. I'm going to have an exception. Okay? So you're seeing here how to use for loops. You're seeing here comments, how to do comments. Okay? And the concept of comment, I assume you know from before. Okay? Now, you just see the syntax difference. When you have an array, you just go and put a subscript there. When you have a string, you say char at. Okay? So this is non-uniform. I mean, the concept is that you're getting the ith index. Okay? But the syntax is different. And the syntax is different because I kind of have the answer here, but you want to say it in your own words? Different people wrote it, and they weren't talking to each other. That's a good answer. That's a good answer, actually. It's happened in Java, but this part came from one guy. Both these parts came from one guy. So one of these things is part of the language, really part of the language. Okay. So it's got, when you have something that's part of some type that's part of the language, there's special syntax for it. And one of these is something you can layer on top. You can replace with your own type. So which is built into the language and which is replaceable. Which seems to be more standard syntax. Array is a standard because intuitive. But in terms of if you were to replace things, when you replace types with your own types, which syntax do you think those types are going to follow? So char at is a lot like $parseInt, right? It's a very extendable syntax. You give the target, you give dot, you give the method name, and that's a syntax. The target could be a class, it could be something called an object. So that's more extendable. The array is more intuitive, it's part of the language, and it's built in, and there's special mechanisms for it. So arrays are built into the library. Strings are a library that can replace with your own objects. They're still part of the language library that comes with the language. So it's a little confusing. You don't have to import it, but it's not got some special syntax for it. Okay? And that's the reason why things are different. The idea is that you could define your own string class. The string was built on top of, there's a layer underneath. On top of that, the strings got built. And that is the reason why strings have a special, different syntax. Okay? Questions? Yeah.
So does that mean that if you remove the for and you just say system on
Sorry, slowly. If you remove which for? This for?
If you remove that for and then in the last line.
Sorry, this for?
No, sorry, the second for. Get down. The
Third for.
Yeah. So if you get rid of that and you say system dot out dot line s, then it's not valid.
No, that's valid. I can say s.char add, then have to give some value here. And this variable I got declared here.
So you can't just say print string.
You can say print string, but here I want to print everything as a character. Each character is on a separate line. I just want to show you the syntax for doing that. Okay? Now, can I break this piece? Can I convert this code into? Can I make it more modular? I could put this code into one main method, and it'll be a monolithic main method. Again, to get practice with creating modular code. Could I break this up? And is there some hint being given to you already? Yeah.
You've taken the length as a parameter, so the length, if you want it to be 0, or use 0 and just put 0 character.
Okay, so you can make this more flexible by just going and saying which element do you want to print. That's one thing, and you can make that a method. But if I don't want to even have this flexibility, I just want the same code with the same functionality, more modular. Am I getting a hint from this picture as to how I might break it up? Have I broken it up visually in some ways? And my comments are telling me also, this part does this thing. This part does this thing. This part does this thing. And, I can feel very good. Oh, I'm commenting. My instructor will love me. I won't. I'll say, you're commenting. You're doing something really bad. Because, if you're writing bad code, sure, comment bad code. But the fact that you're commenting this particular piece of code means that you're actually writing bad code. Because I could replace comments with method names. And my method names, if they're essays, like my method names are, then you know what they're doing. Okay? So, comments versus program decomposition, and I'm being a little heretical here when I say comments are bad. Comments are good when the code is bad, but it's better to have good code which doesn't need that many comments. Okay, despite your best efforts, you will write code that is not as simple to understand as it should be. Then you comment. Okay, but the fact that you have to comment sometimes is a symptom that your code could be more modular. Okay, so the first choice is self-explaining code. And the second choice is bad code with explanations. Okay? And kind of the analogy I'm thinking of right now is, a Shakespearean play versus just a play. So I can have a modular read and print strings, okay, which just goes and, so this is the main method. Rather than the main method, this is the main task, where I'm going to read, I'm going to have so let's try to understand what I'm doing here. Read num strings will be a method that does what? That the first thing that the user types in. Okay? It'll return a value, which I'll go and pass to read strings, which will know how many values to read. So it's going to have that loop that goes in, fills up the array, and it's going to return an array. Okay? Then I'm going to say print strings. I'm going to pass it that array. And then I'm going to say print string, and I've got what you wanted. I'm saying strings of 0. I can say strings of 1, strings of 2, strings of 3. Okay? I don't need any comments now. I don't think so. With these long names. Yeah?
Is there a typo in the public site code?
Oh, yes, there is. There's this extra this thing here. All this code actually works, more or less. The trouble is that when I take from Eclipse and copy it here, I have to reformat it. So sometimes I'm very lazy. I just go and change the PowerPoint when I change the code. Okay? So yes, thank you. And so now here's my read strings. It's self-contained. It says, please print the number of strings. I can change the prompt. And it does, and it uses console.readInt. I don't have to instantiate the scanner. I don't even have to know about instantiation here. And here's my read strings. And so comment is being replaced by a long identifier name. Okay? Your rubric is going to change so that at least 10 points are for good names and other coding conventions. Okay? So we'll talk about case conventions after this. And if you have bad names and comments, that's okay. But that's not as okay, but it's better than having bad names and no comments. Okay? And, I'm such a bad typist that the last thing I should be doing is having these long names. Okay? I mean, you stop. Whenever I try to type, I make a mistake, actually. I'm not a touch typist. And so, but Eclipse comes to our help. I can go and, once I've gone and said read and print strings, I can just say RE and then say control space. And if there's no other variable with that prefix, it'll just complete it for me. Okay? So just get used to this. And if you really don't like this also, have your lousy names and then do a global substitution later. Okay? Or you can refactor also in Eclipse and call it something different. So yes, long names take time to enter, but there are ways around it. Okay? And personally, if you ever seen any, if you've seen some business talks, there are a lot of acronyms there, a lot of buzzwords, where they'll go and have these acronyms that people don't know anything about. And acronyms I've never liked in talks, I don't like in programs, because you forget. I mean, why should I be thinking about what you really meant by these 4 letters? I should be thinking about what the message you're giving me is. Okay? So, and it's not the comments are not useful. I mean, this fact that this is unsafe is a good comment. Okay? So I'm not saying don't comment at all, but I'm saying try as a first choice to use good names. Okay? This is your print string. This is your print string. So print strings prints out this array, and print string prints out one particular element. Okay? So what to write in a comment? Is this a good declaration? No, right? I mean, you shouldn't use W. W could mean anything. But if you're going to use W, might as well comment. Is this a good example? You're commenting for the sake of commenting. Okay? Redundant. I don't need it. Wait. Okay? And is this a good comment? We always said yes. Okay? So it's not that comments are bad, but often you can get rid of them. Okay? In addition to comments, we're going to have some case conventions that Java has, and I'll require you to use it also. And anybody know what some Java case conventions? Yeah. Sorry? What case? And what is the word you use for that? Camel. That's a new word. Oh, really? C-A-M-E-L? Wow. I learned. Mixed case is what I'd say. I don't know. I had long-winded ways of explaining that. Okay? So variable name should begin with the lowercase letter. Other conventions that you might have implicitly seen? Yeah. Class names start with an uppercase letter. Okay? And in C#, in method names, lowercase. In C# they use uppercase. So it's not as if this is sacred, It's just that this is what Java does. So start class name with uppercase letters. So which is the one you want to have? Okay. Start variable and method names with lowercase letters. Okay. And so this is my long way of describing what you guys said succinctly. So which is the correct thing to do here? Okay. So that's something you should be doing. Any other questions about style? You guys can all get the 10 points for style in your program? Okay.
I have one question. Sometimes for really small variables, like how for something,
Sorry, say a little louder. Small variables, meaning small. Okay, so in for loop, can I use I or not? If I wasn't to use I, what would I use? Index. And is anybody going to be confused if you use I? Where do you think this I came from? I for index? J. Why is J used as a, sorry? MATLAB? So there was a language. That was my first programming language because I'm an engineer. Anybody guess what an engineer learns as a first language? No, that is computer scientist language. Yeah, I learned Fortran. Okay? And in Fortran, the type of a variable was not declared explicitly. From what I remember, it's been a long time. And I, J, K, L, M were all integers, and anything else was doubles. Okay? And so this is where the tradition comes from. And you want to use I for loops, go ahead and use it. But I recommend you use index. It just makes things more clear. But you want to use I, J, K for loop indices, that's okay. Okay, I've told you Java sort of by example, and there's more formal definitions possible. Okay, and my own notes for 110 provide you with that. And we're going to look at some of these concepts in more depth later, like exceptions.